Hi everyone, welcome back. Thinking about two particles and how close they go to each other. So if I started here, say, and I shot my pen through the air in that direction, and if I shot this pen through the air in that direction, will they hit each other? But at the moment I don't want to know if they intersect, I want to know how close they get to each other. So if you can see the two of them going through space, they start somewhere and they have a velocity. So if I go back to this question here, if it starts at 3, 1, 1, so if you conceptualise 3, 1, 1, I go across 3 units, I go up 1 unit, I come out 1. So I'd be starting there and I'd be going in the direction of 3, 2, 1. So I'd be starting there and I'd be going across 3, up 2 and out 1. So I'd start there and I'd be going in that direction there. So you can keep going through and looking what they are and talking about how far apart are they, or how close do they get to each other. You could actually do it on the spreadsheet and say where would they be after 0.1 of a second, after 0.2, and figure out when they were closest. So you can do all sorts of calculations, but let's have a look at what we've got. A started at this point. I'm going to write it as 3, 1, 1. I prefer writing it in this form because you don't have to write in the I's and the J's and the K's. And its velocity is 3, 2, 1. So it's going to go across here at 3, 2, 1. So I could figure out where it was after 1 second, I could figure out where it was after 2 seconds, I could figure out where it was at half a second. And the other one then, it starts at 1, 5, 2, and then we're going to go velocity of 5, 1, 2, so that means that you'll go that far in 1 second, and then you'll go on twice that in 2 seconds, and twice that in 3 seconds. So you end up with these two here. So what we're doing is we're getting points in space, and if you had them every second, every 2 seconds, 3 seconds, 4 seconds, you can pretty soon see where they were fairly close to each other and how far apart they were. They don't even have to be close, they might be miles apart from each other, long way apart from each other. Let's have a look at it. If I had any two particles anywhere, if I go from this particle back to the origin across to there, that's the same as going the minus of that one plus that one. So it's actually, I often think of it as if that's A, minus RA plus RB. So I think of it as minus RA plus RB. But it doesn't matter which way you go. If I'm going to go from B back to A, it's minus RB plus RA. So that would be minus RB plus RA. Doesn't matter which way you do it? No. And a lot of people get used to just saying, well, that's the same as saying RB take RA. And that one's the same as saying RA take RB. So when we're talking about the distance between any two particles, we're just subtracting their positions at that point in time. So all I'm looking at is how far apart are A and RB. But instead of having it as numbers, I've got it as algebra. I've got it with a variable. So there's my RA and there's my RB. Now I can go that, take that. I can go that, take that. If you wanted to, you could look at the numbers and make a choice. I've got really simple numbers here. So I've got 3 plus 3t, 1 plus 2t, 1 plus t, and the biggest thing is trying not to make silly mistakes with this. Good part if you're doing an exam and you make a silly mistake, you should still be able to get a lot of marks. So if I just subtracted those two, I've got 3 take 1, I've got 3t take 5t minus 2t, I've got 1 take 5, trying not to make mistakes, 2t take t is 1t, and I've got 1 take 2, and I got t take 2t is minus 2. And I look at it and go, that's 2, minus 2, that's minus 4, 1, and that's minus 1 and minus 1. So then if I want the distance between any 2 points, this is the 2 points, you can get the 2 points after 1 second, or you can go every 0.1 of a second or 0.05 of a second, whatever you want. But we want the distance between RA and RB. And guess what that is? Pythagoras. So Pythagoras comes back in everything. The distance between any 2 points is going to be Pythagoras. Technically, we probably wouldn't call it Pythagoras because we're talking 3D. It's the extra of Pythagoras. But I still, when I'm talking 2D, it would be just Pythagoras. So the distance would be the Pythagoras for that. So there's your I values, there's your J values, and there's your K values. In Western Australia, you've got to underscore everything. If you don't underscore it, you can lose a mark. It has to be there all the time. There are other systems out there. So we've got square root of, we get the I, which is basically talking about, let's get the horizontal part. Or we can say the horizontal component. So let's get the horizontal component and square it. Let's get the vertical component and square it. And let's get the, haven't got a direction, have we? So it's horizontal to the right, and then it's vertical. We'd probably say in this case horizontal coming straight up, which is a bit hard to write that, but I could say it. And that one would be minus 1 minus t squared. Now the interesting part is we want to get where that is a minimum. We're always talking about a minimum and what's going to go on when you get a minimum. We're going to get the derivative. Now the derivative in this case, we're using the letter t, so we're going to get the derivative and let it equal 0. In Western Australia, you could just say, I want to solve where the derivative of that equals 0, but most states don't have the graphics calculator, so they wouldn't be able to do that. So let's go through it anyway in the step form and see what happens. Instead of dealing with a square root, which makes that quite ugly to differentiate, I'm just going to call it the d squared, and I'm going to ignore the square root. Good part about this, you could actually do a lot of the calculation even in a non-calculator section. For those who aren't in Western Australia, we have a third of the paper for year 12 is non-calculator. So then I can get the derivative, d dt, of d squared. Now I'm going to write it a bit different. Because it's a d of d squared, I'm going to make it a little bit more obvious by writing it just there. So that derivative is easy. This is a chain rule, plus a chain rule, plus a chain rule. And the chain rule, I can just go 2 to the front, 2 times the front is 2, and decrease the power by 1, and multiply by the derivative of the inside. So there it is as a rule. So this one's going to be 2 times 1 is 2, and I've got minus 4 plus t, and the derivative of the inside is 1, so I don't have to write that. This one will be 2 outside of minus 1 minus t, and then the power becomes a 1, I don't have to write it, times the derivative of the inside, which is minus 1. So this one's going to be minus 4 times by 2, so that's minus 8, minus 4 times by minus 2t, so that's plus 8t, minus 8 plus 2t. This one will be minus 2 times minus 1, so that'll be a plus 2, and that one will be minus 2t, minus 2 times minus t, so that's plus 2t. And I end up with this expression. So what have I got? I've got that the derivative of d squared is minus 16 plus 2, that's minus 14. And I've got the 8t plus a 2t plus a 2t, so that's 12t. And what I've got to do for a minimum, when I differentiate, I've got to let it equal 0. So I've got 12t equals 14. So I've got t equals, and in this case I've got 14 over 12, or I've got 1 over 6, or whatever you want to say, and it's 7 over 6. Now at that point in time, we know that they were at the closest point after 1 and 6 seconds. So that's when they get to the closest, but that's not how close they got. So how do I get how close they were? I get the square root of all of this thing here. So back to there, it's a 2 minus 2t. And for those with their Classpad, you can do a substitution, but I'm not going to do that for this. I'm going to keep it back to simple calculations. And I've got 2 minus 2 times, a bit yucky, that squared. And then I've got the minus 4 plus the 7 6 squared. I might cut all this out when I do the video. So after using my calculator, this turns out to be the square root of 12.83 repeater. And then I can put that in the calculator again, and I can go that that is 3.58. Question was talking about centimetres, and we're talking about accuracy to 2 decimal places. Oh, wow, I hope it helps. Concept again is we're just going to go subtract the 2 vectors in time. So one of them will be this equation here, the other is that equation there, so I can subtract them. And that is an expression for the distance between them. How do I actually calculate the distance between them? I use Pythagoras, and instead of using that to get the derivative, I can just deal with it without the square root, because it'll still be the closest. Whether you're getting the square of the closest or the actual closest itself works the same. Nice and easy chain rule for each of those. let them equal the naught, find out the time, substitute it back in, and you can find out their actual distance, and there it is as a square root, and then find out as the value. If you enjoy them, I always say just let your friends know. What would be better still would get more subscribers and get some more likes. Thank you very much.